Hello. Today we're going to talk about the 3.4 marginal functions in economics. So this is the application of derivative in economics. Let's start from cost functions. If C of X is the total cost of a commodity at production level X, C prime is called the marginal cost function of the commodity. And the average cost function is defined as the total cost C over production level X and denoted by C bar. And C bar prime is the marginal average cost function. So whenever you see a word of marginal, you just take the derivative of the function. Let's do a simple example. The total cost in dollars of producing X units of a certain commodity is given by the function C of X equal to 400 plus 20X. In this total cost, we got two parts. The first part, 400, is fixed and includes the expenditure of equipment, the machine, and the infrastructure, and so on. And the second part, 20x, goes linearly with the production level, so that includes labor fees, salaries of laborers, and materials, and so on. And there are three questions here. Question A, find the average cost function C bar. Question B, find the marginal average cost function C bar prime. And question C, what are the economic implications for your results? So to find the average cost function, we just divide the total cost C by X to get 400 plus 20X over X. And you can simplify it by splitting the numerator into two terms to get 400 over X plus 20. Part B, the marginal average cost, just the derivative of the average cost. So we got the negative 400 X to the negative 2 or negative 400 over X squared. So you can see the marginal average cost is always negative. So that means when you increase the production level, the average cost decreases. Part C, how do you interpret the results? Let's just take a limit of the average cost when the production level X is very large. So X approaches infinity. So the first term of 400 over X vanishes and we got 20. So what does it mean? It means as the production level increases, the fixed cost per unit of production, represented by the term 400 over X, drops steadily. So we already discussed it. And the average cost approaches the constant unit price of production, which is $20 in this case. So you want to increase the production level to lower the cost. Now let's talk about the range functions and the profit functions. If P equal to Fx is the unit price of a commodity at sales level X, then R equals X times F is the revenue function of the commodity. So the sales level X times the unit price. And the marginal revenue function is just a derivative of R. The profit function of a commodity at the sales level X is P equal to R minus C. So that's just the difference between the revenue and the cost. And P prime is the marginal profit function. Okay, let's do another example. Acrosonics production department estimates that the total cost in dollars incurred in manufacturing X electrostat speaker systems in the first year of production will be C of X equal to 200X plus $300,000. And the marketing department has determined that the demand function for these speakers is P equal to negative 0.04x plus 800, where P denotes the speaker's unit price in dollars. So that's just the demand function we discussed before. We need to do three questions. Question A, find the profit function P. Question B, find the marginal profit function P prime. And question C, compute P prime at 5,000 and the P prime at 8,000. So to find the profit function P, we just take a difference between the revenue and the total cost. And the revenue R is just the X times P. And so we can plug in P equal to negative 0.04x plus 800 and C equal to 200x plus 300,000 in the formula to get P equals R minus C which is xp minus c of x equal to x times negative 0.04x plus 800 minus 200x plus 300,000. And we'll get negative 0.04x squared plus 600x minus 300,000. The marginal profit in question B is just a derivative of the profit. So we got negative 0.08x plus 600. Question C, P prime of 5,000. Just plug in 5,000 for x to get negative 0.08 times 5,000 plus 600. We got 200. P prime of 8,000. So plug in 8,000 for x. We got negative 0.08 times 8,000 plus 600. We got negative 40. So what happens here is when the sales level is low, the marginal profit is positive. So you are making money. You increase the sale level. But when the sales level is high, then the marginal profit is negative. You don't make money anymore, even though you are selling more, because the price is too low. All right, there is an important concept in economics called elasticity of demand. So suppose you want to know the effect of change of price on the demand. Okay, so you want to raise the price of the commodity, but you don't want the sales drop too quickly. And then you can use the elasticity of demand to measure this property. So if f is a differential demand function defined by x equal to f of p. So this is the demand function we talked about before, but we are writing the demand as a function of price instead of price as a function of demand we did before. So this is f. Then the elasticity of demand at price p is given by E of p equals negative p times f prime p over fp. So you are considering the change of unit price on the change of the demand. So the demand is said to be elastic if E of p greater than 1. And that means a small percentage change in the unit price will result in greater percentage change in the quantity demanded. All right. So you want to raise the price, but if the demand is elastic, then you get a big drop in the demand. So you actually lose money. So it is not good if the demand is elastic. And demand is said to be unitary if E of p equal to 1. The small percent change in the unit price will result in approximately the same percent change in the quantity demanded. And the last case, the demand is said to be inelastic if E of p less than 1, and the small percentage change in the unit price will cause a smaller percent change in the quantity demanded. And that is good. So you can raise the price and you don't drop too much in the sales. So this is the end of the section.